Hi, welcome to my YouTube channel Electronics for Gate by Kota Venkanna. My mobile number 630-5826-909. Today I want to discuss the topic of Biot Savart's law. So here, before going to study the Biot Savart's law, we have to discuss the magnetic fields, study magnetic fields. Here, study magnetic fields produced by steady currents. So, steady currents produce steady magnetic fields. So, steady magnetic fields which are constant with time, these fields are called as static magnetic fields or magnetostatic fields. So these fields are described by magnetic field intensity H and magnetic flux density B by using this relation B is equal to mu into H. And steady magnetic fields are governed by Biot-Savart's law and Ampere's circuit law. So that's why today we have to discuss Biot-Savart's law. So in this Biot-Savart's law, consider a conductor. Here in Biot-Savart's law, so here this is a current carrying conductor. This is current carrying conductor. This carrying current is a direct current I, and it produces a steady magnetic field produced by this current. So the differential magnetic field intensity here at the point P, the differential magnetic field intensity produced due to the current element IDL, So here consider the length DL. Consider the length DL. Hence, the differential current IDL, the differential current element here, the differential current element is indicated with IDL, differential current element. And this is a very small part of the current carrying conductor. IDL, DL is a small part of current carrying conductor. So at the point P, the distance is R. The distance is R from point P to the small amount of current carrying conductor DL. That is R. And the line joining the point. So in between current element and the line joining the point P, in between the angle is theta. So from this diagram, the Biot-Savart's law states that here DH, the magnetic field intensity, the differential magnetic field intensity DH, directly proportional to I into small dl, and the direct current, the conductor carrying the direct current I, and dl is the small area of the current carrying conductor dl. This is the dl. So here at the point P, the differential magnetic field intensity directly proportional to IDL as per the Biot-Savart's law. So Biot-Savart's law states that dH directly proportional to ideal and dH directly proportional to sin theta. So here angle between the current carrying conductor and the point line joining the point P, in between these two angle theta is there. So that's why dH directly proportional to sin theta and dH inversely proportional to square of the distance from point P to the small current carrying conductor VL. So that is inversely proportional, square of inversely proportional, that is square. So that's why the combining these three which can be written as dH directly proportional to ideal dl sin theta by r square. So it directly proportional, when these two are directly proportional, it is written as equal in between these two, then it can be written as dH is equal constant 1 by 4 pi. It is constant 1 by 4 pi ideal sin theta by r square. So it is vector quantity. So the vector quantity is written as AR. It is indication for vector AR. So the final Biot-Savart's law equation is written as dH is equal to 1 by dH is equal to ideal sin theta by 4 pi r square AR. So this is the Biot-Savart's law in differential form, and this also which can be written as AR. Here AR is written as R dash by module of R. So when this AR is applied in this equation, then dH is equal to ideal sin theta by 4 pi r square into r bar by r. And finally the equation is written as dH is equal to ideal sin theta by 4 pi r square into r cube into r bar. So this is the differential form of Biot-Savart's law. And then integral form. How it can be written as integral form? So before going to integral form, basic equation is dH is equal ideal sin theta by 4 pi r square into AR. This is the basic equation. So here the differential form is AR, it is written as R bar by R. So before that we have to take it as DH is equal ideal sin theta by 4 pi R square into AR. R is the vector quantity. So here differential form. We want H. How it is possible? By integrating both sides. So by integrating both sides, integration of dH is equal to integration of ideal sin theta by 4 pi r square 4 pi r square AR. So differentiation of differentiation both are cancelled. So that's why electric field intensity H is equal to integration of ideal sin theta by 4 pi r square into AR. So this is the integral form of Biot Savart's law. Here AR is written as R dash by module of R. So units are Biot Savart's law. H is equal, units here ampere per meter. This is the integral form of Biot Savart's law. In the next class, we will discuss Ampere's circuital law. Thank you for daily classes. For any doubt, subscribe my channel. My channel name is Electronics for Gate by Kota Venkanna. Thank you.